Alright, welcome everybody. So today I want to go over section 3 of this unit with you guys. So we have been doing different things with the radicals and exponents. I know we started section 3 last class, but we didn't get a chance to finish it. So I want to go over that today. Alright, so if you have your notes, you can follow along. But if not, feel free to write this down, or you can just watch the video. Make sure you pay attention because there will be an assignment on this after you're done. Okay, so for section 3 of this unit, we're going to look at the different properties of exponents. Okay, what do we do with exponents when we divide them, multiply them, and so forth? So the very first property is something that we call product of powers. Alright, so all that means is that if we're multiplying a variable with, or two variables that have exponents, okay, to get the answer, to simplify, what we do is we add the exponents. So for example, let's say I've got 2 squared times 2 cubed, then the answer would be 2 to the 5th. Okay, a lot of people try to multiply these. Don't multiply them, you're going to add them. Okay, so 2 squared times 2 cubed is going to be 2 to the 5th. And of course, you can just type that into your calculator, you'd get 32. Alright, the second one is what we call the power of a power. Alright, so what that means is if we have a variable to the m power raised to another power, okay, that's when we're going to multiply those two exponents. Alright, so again, for example, let's say we have 3 squared. Okay, so in that case, we're going to multiply these two exponents. So 2 times 2 is 4. So 3 to the 4th, which would give us 81. Just another example for y'all to see. So let's say we have x to the 4th to the 5th power. Again, we're just going to multiply these two exponents. So that would give us x to the 20th. Our third property is what we call power of a product. Alright, so let's say there's two things being multiplied, so a times b, but that whole thing is raised to the m power. Alright, so when that's the case, what we're going to do is we're going to distribute this exponent to both things. Okay, so that's going to be a to the m times b to the m. Okay, so kind of like what we do when we distribute, when there's parentheses, we're going to distribute that exponent to both factors. Alright, so to give you an example with numbers, let's say I have 3 times 4 squared. Okay, I'm going to distribute that squared to the 3 and the 4. So 3 squared times 4 squared, so 3 squared is 9, 4 squared is 16, and 9 times 16 is 144. Okay, so again, just so you see that with like an x and a y, so let's say you've got x squared, y squared. Okay, so again, you're going to distribute that squared, so that's x squared times y squared. All right, well, we just learned earlier that if something has an exponent and it's raised to another exponent, we're going to multiply those two. So that becomes x to the 4th y squared. All right, the next property we're going to talk about is negative exponents. Okay, so for example, let's say, first of all, negative. Let's say I have a to the negative m power. All right, anytime you have a negative exponent, that's the same thing as saying 1 over a to that same exponent. Okay, so if you have a negative, basically you're just going to move it to the bottom of the fraction. So let's say I have 3 to the negative 2 power. Well, that's the same thing as 1 over 3 squared. And of course, 3 squared is just 9, so 1 to the 9th. Again, let's look at another example with x. So let's say we have x to the negative 4th power. So that's just going to be 1 over x to the 4th. All right, the fifth property is going to be, this one's probably the easiest one. It's what we call the zero exponent. Basically what that tells us is that anything to the 0 power is always going to equal 1. It doesn't matter what the number is. It doesn't matter if it's negative 544 to the 0 power. That's kind of like a degree symbol, sorry. A 0 power, that's going to be 1. Or a fraction, say 56 over 23 or 22 to the 0 power, that's also going to be 1. Same thing with variables. So if we have x, y raised to the 0 power, that's also going to be 1. So anything to the 0 power is always going to be 1. All right, our sixth property is going to be what we call quotient of a power. All right, so what that means is, let's say you have some number or variable raised to a power. On the bottom of the fraction, you have that same number or variable raised to another power. All right, it's always going to be, you're going to subtract the two exponents. So this one, most of these y'all probably should have seen before this. This one might be kind of newer. So, for example, let's say you have 5 to the 10th power over 5 to the 8th power. Okay, so since these numbers are the same, I can just subtract these two exponents. So 10 minus 8 is going to be 2. So 5 squared is going to be 25. Or what if the bottom number is bigger? So let's say you have 3 to the 3rd power over 3 to the 5th power. All right, well, if you subtract 3 minus 5, that's going to be 3 to the negative 2 power. Well, we learned up here that when you have a negative exponent, you're basically going to put that number on the bottom of the fraction to get rid of the negative. So 1 over 3 squared, which is just 1 over 9. Another way you can think about that one is just always subtract the bigger number from, or always subtract the smaller number from the bigger number. So 5 minus 3 is 2. Well, I did 5 minus 3, so I'm going to put my answer down here. All right, so if it's quicker for you to do it that way, just take the bigger number, subtract it, or subtract the smaller number and write it wherever the bigger number started, then do that. Or you can just do this and then use your negative exponent rules to move whatever you need to around. All right, one last property I want to talk about is power of a quotient. All right, so these are kind of similar, but a little bit different. So power of a quotient means you have some kind of fraction that's raised to a power, let's say m. All right, so power of a quotient is going to be very similar to power of a product. So just like up here, how we had to distribute the exponent to both parts of the product, same thing here. We have to distribute the exponent to both parts of the quotient. So this is the same thing as a over m times b over m. And so again, just so y'all see that with numbers, so let's say I have 2/5 squared. Okay, so I'm going to distribute the squared to both parts of the fraction. So that's 2 squared divided by 5 squared. Well, I know 2 squared is 4, and 5 squared is 25. So my answer is 4 over 25. All right, same thing if you have variables like x and y. So let's say I have x over y to the 4th power. That's going to be the same thing as x to the 4th over y to the 4th. Okay. All right, so that is all of your properties of exponents. So let's go and take a look at how we can use these to simplify expressions and solve problems with it. So let's say I have x to the 2/3 power times x to the 7/3 power. Okay, one thing that might be really helpful for a lot of y'all is, first of all, just figure out which property are we going to use to simplify this one. Okay, so take a look at what we have here, and it looks like it's going to look the most like this one, number 1, product of powers. All right, so when that's the case, we're just going to add the exponents. All right, so when you're adding fractions, okay, you can add them as long as they have the same denominator. So if it didn't have the same denominator, we would have to change it, but since they're both 3, we can just leave it. All right, so when you're adding fractions, you're just adding the top number, and then you're leaving the denominator the same. So 2 plus 7, that's going to be 9. So that's going to be 9 over 3, which we know is the same thing as 3. All right, so this is going to simplify to x cubed. Okay. All right, let's do another example. Say we have r to the 10th times 1/5. Okay, again, let's figure out which one that's going to be. Okay, so if you're having a hard time figuring out which property you're going to use to simplify the example, use the process of elimination. For example, I know it's not going to be 0 exponent, so there's not a 0 as an exponent. It's not going to be quotient of a power or power of a quotient because there is no fraction. The main number is not a fraction. So that leaves me with one of these up here. Well, nothing's negative, so it can't be that one. All right, so it looks like it's going to be this one. Okay, there's one exponent, and the whole thing is being raised to another exponent. All right, so if we look at that one, to simplify it, you just multiply the exponents. So here we're going to do 10 times 1/5. Okay, so fractions, you just multiply across, so that's the same thing as 10 divided by 5, which simplifies to 2. Okay, so my final answer is going to be r squared. All right, let's go and take a look at another example. Okay, so we have x to the 4th y times 1/2. All right, so we're going to use two different properties for this one. The first one is this is going to be a power of a product. Okay, there's two things being multiplied and they're being raised to another power. Okay, so when we're doing that, we're going to distribute this 1/2 to both parts of the product. So I'm going to do x to the 4th to the 1/2 power, and then y to the 1/2 power. All right, well, we never want to leave an answer like this. Okay, remember to simplify that, I'm just going to multiply these. So half of 4 is going to be 2, so that's going to end up being x squared, and then y to the 1/2 power. All right, let's take a look at another example. So let's say we have 10 x squared over 5x to the 9th y. All right, so let's just take this one thing at a time. Okay, let's start with the numbers. 10 over 5, that's going to reduce to 2. So I know if this is a fraction, there's going to be a 2 at the top. So I've taken care of that. All right, so remember when you're doing when there's an x here and an x here, and they both have an exponent, okay, always just subtract the smaller number from the bigger number. And if the bigger number is on the bottom, that means that that letter is going to be ending up on the bottom. So since x to the 9th is bigger than x squared, I know x is going to be on the bottom. So to figure out the exponent, that's just going to be 9 minus 2, which is x to the 7th. And this y is on the bottom. There's no other y, so that's not going to change at all, so that y is just going to stay on the bottom. So to rewrite my answer, so it just kind of looks better, it's going to be 2 over x to the 7th y. Okay, let's keep looking at a couple more examples. So let's say we have 8,094 to the 0 power. Again, that's going to be the easiest one. Okay, remember anything to the 0 power is just going to be 1. So it doesn't matter what the number is. If it's to the 0 power, the answer is going to be 1. All right, let's take a look at one that has negative exponent. So let's say 28 x to the negative 3rd. Remember, anytime there's a negative exponent, that just means that you're going to move it to the bottom. So x to the 3rd is going to be at the bottom of the fraction. Nothing happens with 28, so we're going to leave that up top. All right, and then let's look at one last one together. Let's look at 7x over y squared raised to the 3rd power. All right, so again, this is that last one we talked about, power of a quotient. Okay, so if the whole quotient is being raised to a power, I'm going to distribute that power to the top and the bottom. So I'm going to do 7x cubed over y squared cubed. Okay, so we're going to use a couple different properties for this one. All right, so first of all, at the top with the 7x cubed, all right, this is a power of a product. Okay, which means there's two things here being multiplied and raised to the third power. So I'm going to distribute that cube to both things. So 7 cubed times x cubed. On the bottom, this is the power of a power, which remember, when there's two exponents like that, you're just going to multiply them. So 2 times 3, that's going to be y to the 6th. All right, well, we're not going to leave 7 cubed here. We can go ahead and multiply that out. If you type that in your calculator, you should get 343. X cubed stays the same, and y to the 6th stays the same. All right, so there's some examples of all of them. Feel free to go back and stop it if you're having trouble with any of them, and then try to do the practice problems. Let me know if y'all need any help.